Hello Year 10. Today we're going to be talking about exponential growth and decay, but to do that we need to have a good understanding of our exponential equations, so we're going to quickly sketch a few up here as a revision of our last lesson. So sketch the following on the same set of axes, labelling the y-intercept and the point where x equals 1. So we want to start with y equals x to the power of 5. The y-intercept is when x equals 0, 5 to the power of 0 is 1. So 1 will be there, I'll put a 1 next to it as my intercept. Then I want to sub in that x is equal to 1, which will be here. 5 to the power of 1 is 5. So that will be my second dot. And knowing the shape of my exponential, it's going to start really small and then start coming up like that. Okay, then moving on to the next one, we want to do 2 to the power of x. So again, the y-intercept is when x equals 0, so 2 to the power of 0 is 1. Then, when x equals 1, 2 to the power of 1 is 2. So this one's a little bit higher on the left side, but shallower on the right-hand side. So that's y equals 2 to the x. And for the last one, y equals 10 to the x. 10 to the power of 0 is still 1, and then 1 to the power of 10 is 10. Very, very steep. So very small on the left, hits that intercept, and then extremely steep, y equals 10 to the x. Remember to include your horizontal asymptote. So dotted line across the bottom. The horizontal asymptote is when y equals 0. Okay, so exponential growth. There are practical situations where things grow exponentially. And we're going to learn about a formula here. It says the basic exponential formula can be summarized as a equals a0 bracket 1 plus or minus r over 100 to the power of n. Now, hopefully that formula kind of looks familiar. It's a bit like the compound interest formula. The plus or minus in that formula means that we can use this formula to do both exponential growth and exponential decay. So if you think of things like radioactive isotopes, things that have half-lives, things that are decaying over time, or you could think about things that are depreciating, things that are going down. If you have that kind of scenario, then you're going to use the minus in that formula. So that one is for decay, or anything that's getting smaller. And you use the plus if it's for growth. The A0 represents the initial amount that you start with. The A, the normal A that's over here, is the total amount that you would have at the end. R is the interest rate that is as a percentage, which is why you divide it by 100 in the formula, and N is the time period. Okay, so let's have a look at our questions. Example number 1, form exponential rules for the following situations. And A says, John has a painting that is valued at $100,000. It is expected to increase in value by 14% per annum. So it's increasing in value. So the formula that I'm going to use is the A equals A0, 1 plus R over 100 to the power of N. I want the one that's increasing. Okay, so the starting value of the painting is the 100,000, so that's the A0. The 14% here is the R. I don't know what N is, that's why I'm making an equation here. So it will still be in an equation form when I finish this off. So subbing in what I do know, A is going to be equal to 100,000 and then bracket 1 plus R, which is 14 over 100 to the power of N. Now all I want you to do to tidy that up is tidy the bracket. So we have 100,000, 1 plus 14 over 100 is 1.14 to the power of N. That is the rule And if we wanted to continue with this question, you could then say, all right, what is the painting going to be worth after 3 years? So you'd sub in n equals 3. Or what's the value worth after 50 years? Sub in 50. That equation represents the growth of the painting over, growth in the value, of the painting over time. Let's go on to part B. We have a city's initial population is 50,000. It is decreasing at 12% per year. So decreasing means that we want to use the formula that has the minus sign in it. It'll be 1 minus r over 100 to the power of n. This time the A0 is the 50,000 and the r is the 12%. So we will get 50,000, 1 minus 12 over 100 to the power of n. Like last time, leave the 50,000 there, but tidying up the bracket, you could type it in. You go 1 minus 12 over 100. Decimal, though, will be 0.88 to the power of n. And again, that would give you a graph, if you graphed it, of the exponential as it is the value of this, not value this time, it is a population of people, that what the population is doing over time. Question 2. House prices are rising at 7% per year and Andrew's apartment is currently valued at 400,000. Determine a rule for the value of Andrew's apartment where we're using V dollars in n years time. Okay, so down here, part A. Because his apartment is going to be rising in value, we're going to use the formula A equals A0 bracket 1 plus r over 100 to the power of n. The initial value, the A0, is the 400,000 and the r will be the 7%. So 400,000, 1 plus 7 over 100 to the power of n. Or to tidy it, 400,000, 1.07 to the power of n. Then to do part B, it says what will be the value of his apartment next year. So it actually wants me to find specific values after a certain amount of time has passed. So part 1 next year means that 1 year has passed, so I'm going to sub in that n is equal to 1. That would give A equals 400,000, 1.07 to the power of 1. And you can type that in your calculator. You go 400,000 times 1.01 to the power of 1, which is $428,000 that the apartment is now worth. Part 2, we want to know the value of the apartment in 3 years' time. So we go back to our original equation and we're going to sub in 3 now. So it's 400,000, 1.07 to the power of 3. So it's now worth 490,000, $17.20. Okay, so it's increased by quite a lot in just 3 years. Over the page to question 3. The half-life of a substance is 100 years. Find the rate of decay per annum expressed as a percentage correct to 1 decimal place. Okay, if it's a rate of decay, it means I'm going to use the formula A equals A0, 1 minus r over 100 to the power of n. Okay, now a half-life means that you have half of the original substance left. So when the time is 100 years, the A, the amount that is left, is going to be half of the initial amount. I don't know what the initial amount is, so I'm saying half of A0. If I put those two things into my equation, the A becomes half of A0 equals A0, 1 minus r over 100. I'm trying to find out what the r is. I shouldn't have used t, sorry, it's n. N for the number of years, so it's to the power of 100. Okay, now the cool thing is, if you have an A0 that is multiplied to each side of the equation, they can cancel out. So that disappears altogether, and we just have the half left on the left-hand side of the equation. The next thing I want to do is to get rid of this power of 100. Now we know the opposite of squaring something is to square root something, the opposite of cubing something is to cube root something. So the opposite of a power of 100 is a 100th root. Yes, that does sound like a very big number to be putting on a square root, but that's what we need to do. So we're going to have 1 minus r over 100. That's the bracket. And the power of 100 comes across the other side, and it's going to make a hundredth root of a half. So I need to calculate that. So a 100th root, we can do shift that button to bring up the proper square root sign that I need. Put the power of 100 on that, and then I'm just going to put 0.5 or half underneath there, and we get 0.99309. I'm going to keep a few of those decimal places because I'm not finished calculating yet, and I don't want to bring in any errors too early. So 0.993092, that'll do. Okay, I'm still trying to work out what r is, so I need to move some more things away. The next thing I'm going to do is I'm going to minus 1 to both sides to get rid of that, and that will leave minus r over 100 equals, so from this number I'm subtracting 1, and I get, it did it twice. It should be that one, which is minus 0.0069. 07. Okay, then finally, I can get rid of the minus sign and the 100 in the same go if I multiply by negative 100. That will get rid of that, and r will be by itself. So here's my calculator, times by negative 100, and we get 0.69, and that would be the percentage. Looking back at the question, it does say the final answer needs to be to 1 decimal place. So I'm going to round that to be 0.7, and that already is the percentage because remember that we had the divide by 100 in the formula, so that is 0.7%. All right, now I need to do exercise 3G.